Hi Natalia, so you're asking me earlier, and I believe you had a chat with Mr. Bunting about how to draw this ion, polyatomic ion here with aluminium and fluor chlorides, right? So that means that we have an extra electron here, right? But you're going to have to draw 4 of the chlorides and 1 of the aluminiums, right? And this is the outer shell of each, right? You know, you have inner shells, but we're only focusing on the outer shell. So what Mr. Bunting, I believe, explained is what would happen essentially if this was an ionic compound, okay? So we know that when we have ionic compounds, well, we have our 3 electrons and our 7, and so we would have 1 electron move, okay, and now these have 8, and now the chlorine is happy, you have an ionic chlorine, and then your aluminium has lost 1, but this would happen another 2 more times with the aluminium, and so with 2 more chlorines, potentially you would donate the other 2, and you'd end up with something like this. Essentially, your ionic bond, your aluminium has lost the 3 electrons, it would have an empty outer shell, and each of the chlorines would have received 1 of those electrons, okay? This is in the case if it was an ionic bond, but you're still in the ionic bond, remember, we're showing where the electrons are coming from, okay? The electron came from the aluminium, so you'd still show this electron being different, and in the end, you would have the different electrons, even though the aluminium doesn't have any, okay? This is in general when you're showing an ionic bond. However, if we look at the electronegativities for aluminium chloride, actually, and you know this because it's in the context of a dative bond, and those are covalent, actually the difference in the electronegativity, and you can look at that in your table in the book, is just 1.5, which means it's polar covalent, okay? It's not, the difference is not high enough for it to be ionic. So if we go back to that, we would be able to know that they're sharing the electrons, and so you knew this from the aluminium, right? Combining the aluminium and the chloride, if we're sharing the electrons, same as what we had before, but just the electrons are shared instead of it being empty, right? Because it's a covalent bond. This shouldn't be different to you. But what we have now is this is 3, but we knew that we had to have 4, right? So now it's just where this extra electron comes in. Okay, that extra electron is going to be an extra electron. Obviously, we don't really know where it is, but we can start off by thinking, well, we could have the extra electron here and have this chlorine ion, right? I could have put it here for the aluminium, but really we're thinking of this extra electron, so I could actually draw it as with a different shape, right? We had the triangle as an example in one of them. It comes from somewhere else, but we can think of it as essentially being part of a chlorine ion, okay? If I draw it here as a triangle, that's a possibility as well. And so what we have now is that when we combine this chlorine ion, okay, that extra negativity, with what we had here with the covalent compound, what we actually have is that we have the empty space here for the aluminium, right, because we don't have the 8 yet, right, we don't have the full shell, and we can bring those 2 from the chlorine, and those can be shared to that space in the aluminium, and that's our dative bond, okay, this is our dative bond. Because we're sharing the electrons are being shared, but they're coming both from the chlorine, right? So if we can do our little triangle to say that it's an extra one, but whether we do it as a triangle or we can do it as a dot doesn't really matter because we can think of this as coming from a chlorine ion. Okay, they're still now shared. It's not an ionic bond, it's still shared, but they're both of the electrons are coming from the chlorine ion. Okay, and that's our showing of the dative bond. And we can do our displayed formula showing it like this. We have our aluminium in the middle, and we have our bonds, chlorine, 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 right? And so we show our dative bond. Where are the electrons coming from? They're coming from the chlorine, so we draw an arrow in this direction to show that bond. Okay, I hope that was helpful or useful. And if not, we can talk about it tomorrow.